In part 1, we are to evaluate this by making use of the method of difference. So let's try to expand this. When r is equal to 1, this will give us a 2 to the power of 3 minus away 1 to the power of 3. And when r is equal to 2, this will become 3 to the power of 3 minus away this will be 2 to the power of 3. And when r is equal to 3, this will be 4 to the power of 3 minus away 3 to the power of 3. And now we are seeing a pattern of cancellation, which is going to be in accordance to this. And we are suspecting that this pattern is going to continue all the way until the very last few terms. So in order for us to verify that, let us write down the last two r, which is when r is equal to the term that is before this, which is n minus 1. So when r is equal to n minus 1, we will have n to the power of 3 minus away n minus 1 to the power of 3. And finally, when r is equal to n, this will become n plus 1 to the power of 3 minus away n to the power of 3. And we're seeing exactly the same pattern of cancellation. So we can imagine that all the terms that are in between will be cancelled in according to the same pattern. So what we're going to be left with will be this, which is going to be n plus 1 to the power of 3 minus away this, which is going to be 1 to the power of 3. This is 1, and this is what the question wants us to show. In part 2, we are supposed to show that summation of r squared is equal to this expression over here. And to do that, I'm going to make use of the result from part 1. So let me quote it down here, the result from part 1. If I were to sum from r is equal to 1 to n of r plus 1 to the power of 3 minus r to the power of 3. This is equal to n plus 1 to the power of 3 minus 1. This was what we shown in the previous part. So what I'm going to do is I'm going to expand this expression over here. So summation from r is equal to 1 to n. The expression that is inside here, it is going to be equal to r to the power of 3 plus 3r squared plus 3r. Plus 1, then minus away r to the power of 3. This is equal to, I'm going to expand this also, okay? So it will be n to the power of 3 plus 3n squared plus 3n plus 1. And I'm going to minus 1 from here. This minus 1 is from here. So this over here, r to the power of 3 and r to the power of 3 can be cancelled. So within this summation notation, we are going to be left with just a 3r squared plus 3r plus 1. As for this over here, we will have n to the power of 3 plus 3n squared plus 3n plus 1 minus 1, they will disappear. So now I'm going to break up this summation into different parts. So if I were to break it up into its parts, it is going to be 3 times of summation from r is equal to 1 to n of r squared. That will be from this, plus 3 times of summation from r is equal to 1 to n of r. That is going to be for this. And summation from r is equal to 1 to n of the number 1, a constant. This is n to the power of 3 plus 3n squared plus 3n. As for this is actually the summation that we are supposed to show. So I'm going to leave it as it is. So it is going to be 3 summation from r is equal to 1 to n of r squared plus 3 times of summation of r. This is a result that we know. We can look at it in our theory outline on Achevas TV. So for this over here, we are going to rewrite it as n times n plus 1 divided by 2, making use of the result that we have quoted on the Achevas TV. So this is summation of a constant. Summation of a constant is going to be, again, using the result that we have on Achevas TV. It is going to be the constant multiplied by the number of terms, which is n minus 1 plus 1. This is equal to n to the power of 3 plus 3n squared plus 3n. This is 3 summation r is equal to 1 to n is, here is r squared, plus this is going to give me a 3 over 2n squared plus 3 over 2n. Then this is going to be just n, so plus n. This is equal to n to the power of 3 plus 3n squared plus 3n. So we have 3 summation from r is equal to 1 to n of r squared. Bring this entire expression here over to the right hand side and simplifying together with what we have on the right hand side, we will have n to the power of 3 plus 3 over 2n squared plus 1 over 2n. So now what I'm going to do is I'm going to factorize out n over 2, which will then leave me with a 2n squared plus 3n then plus 1, which we can further factorize this. N over 2, factorizing this will give me a n plus 1 times 2n plus 1. And now we are really close to what we are trying to show here. And dividing by 3 on both sides, the summation from r is equal to 1 to n of r squared. This is going to be equal to n over 6, n plus 1, and 2n plus 1. And this is what we are trying to show. In part 3, we are supposed to evaluate this. Summing from r is equal to 5 all the way until n of r plus 2 square. So in order for me to evaluate this, I'm going to make use of the result that we have derived in part 2, and at the same time, I'm also going to make use of the process that we have highlighted on the Achevas TV outline, which is the replace r by r plus p process. So if I can just replace this r by r minus 2, I will actually be able to get a summation of r squared, which is what I want because that is from the result. With that, we can make use of the result that we have from part 2. So I'm going to replace r here by r minus 2. I'm going to replace all the r here by r minus 2. So r minus 2, this is equal to 5 all the way until n plus 2. Okay, this is according to the process that we have discussed. So this r here, I will also replace it by r minus 2, then plus 2 square. So we are going to be getting a r inside here. So it will be r squared. So the next step here, minus 2, if I were to bring it over to the other side, r will now start from 7 all the way until n plus 2. And now we have an r squared. But if I were to make use of the previous result, I need here to be equal to 1. So I'm going to rewrite this. I will rewrite this such that it is going to be equal to r starting from 1 all the way until n plus 2 of r squared minus away r starting from 1 all the way until 6 of r squared. Because by doing so, by minusing from the first term all the way until the sixth term, from here, we are going to be left with the 7th term all the way until the n plus 2 term. So for this, we can then make use of the result that we have from the previous part, just that we need to replace all this n here, these 3 n's here, by n plus 2. So it is going to be n plus 2 over 6. Then here, I'm going to replace it by n plus capitalized n. So it is going to be n plus 2, then plus 1. Then this n here, I'm also going to replace, so it's going to be 2 times of n plus 2 plus 1. Then I will minus away this, which I'm going to replace now this n here by 6. So it's going to be 6 over 6, then 6 plus 1, then 2 times of 6 plus 1. So this is equal to 1 over 6 of n plus 2. Then this is going to be equal to a n plus 3. This we will have a 2n plus 5. Then minus away this, it is going to be equal to 91.